So we have two standard forms of the hyperbola. One is x squared over a squared minus y squared over b squared is equal to 1. And the second one is y squared over a squared minus x squared over b squared is equal to 1. So the first one lies on the x-axis. The second one lies on the y-axis. And all these two have the center at the origin. We also have x minus h squared over a squared minus y minus k squared over b squared is equal to 1, and y minus k squared over a squared minus x minus h squared over b squared is equal to 1. Again, lying on the x-axis and on the y-axis with the center translated. Then the hyperbola has a bit of some properties also. One, when you sketch a hyperbola, for the first ones here, you can place circles of this nature. This is for 1. Then it will have the lines that you call the asymptotes. We have the lines that we call the asymptotes. Then it will have these guys that we call the vertex. So we'll have the vertex here, vertex here. We'll have the focus. We'll have the focus. So A will be this distance here, and C will be this distance here. This will be C. And then the directrix will have y is equal to plus or minus a over b x. So that for the other one, which is a bit detailed now, I will have, if I place it on the, now I'm taking this one on the y. So I place it on the y. On the y. Then this guy is negative c. This guy is positive c. And then this guy is a. This one is negative a. And then we'll have the line of symmetry, the asymptotes. For this case, our asymptotes will be y is equal to plus or minus b over a x. So you notice a switch here. When it is on the y-axis, we have b over a. When it's on the x-axis, we have a over b by asymptotes. So what are then the properties of the hyperbola, especially the shifted? The other one is an easy case because we have the focus just A, the focus just C, negative C, and the vertex just A, negative A. Now, what about the one that is shifted? That has been tampered with. So say if we have x minus h squared over a squared.
Sorry, sir. The previous screen.
Okay.
All right, thank you.
So here we say if we have this as our equation, then one, the length of the transverse axis is 2a. The transverse, that is moving from one vertex to another vertex, and then the coordinates of the vectors are h plus or minus a, comma k. So hk is center, then you move a and negative a steps, you have your vectors, and then the co-vectors co-vectors coordinates so these now move to, we have h, k plus or minus b, and then we'll have the length of the conjugate axis 2b. So when you form the box around the asymptotes, the length in between is 2b, and then you have distance between the foci is 2c, where in this case c squared is equal to a squared plus b squared. So c is bigger than a, c is bigger than b, and then the foci we have h plus or minus c comma k, and then the asymptotes, when you shift, we have y is equal to plus or minus b over a x minus h plus k. That is the case. So that if we have y minus k squared over a squared minus x minus h squared over b squared is equal to 1, then we'll have 1 the length of the transverse axis as 2a, and then the coordinates of vectors we get h k plus or minus a, and then conjugate the conjugate axis to b, and then co-vertex h plus or minus b k, and then the foci distance is the same, so just talk about the foci coordinates, which is h k plus or minus c, and then the asymptotes are y is equal to plus or minus a over b x minus h plus k. This is for the parabola. It also has the eccentricity, so you can talk about the eccentricity also here, where E is given by the root of a squared plus b squared over a. This is simply c over a, and then the directrix so since there are two, say x is equal to plus or minus a squared over the root of a squared plus b squared, which would say plus or minus a squared over c. So nothing changes here with the other one that had e. It's just that you work out the e, you substitute what e is.
So, sir, basically, this concept is more like the same with ellipse, but there's just a bit of addition of information.
Yes. That's the same. Because the eccentricity goes through parabola, hyperbola, ellipse. It's obtained using the same formula, except that what differs is how you obtain c. No, you don't talk about c for the parabola, so you talk about c for the ellipse, and then there we obtain it by subtracting a squared minus b squared. But for the hyperbola, you add the two, because c, as you can see here, it's rather than a, so it can be smaller. For the ellipse, it sits inside.
Yes, sir.
Yes. Okay, so now this eccentricity, we're saying we can use it to determine whether you're having a conic section as a parabola, as an ellipse, or as a hyperbola. So just put on record that this eccentricity, which is a, is equal to c over a. We're saying if this a is equal to 1, then you're talking about the parabola. 2, if this e is less than 1, then you're talking about the ellipse. 3, if this e is greater than 1, then you're talking about hyperbola. 1, 2. We can also have equations where it's not factorized. Dx plus ey plus f is equal to 0. This is a general equation. Now in the general equation, we also have in here what we call b squared minus 4 ac, which is called the discriminant. You remember this in first year. But here it's also used to detect if what you're having, if it comes in this form, if you have a parabola, hyperbola, or an ellipse. How then do we detect? So we say 1. So we say if 1 b squared minus 4ac is equal to 0, then we'll have the parabola. 2, if b squared minus 4ac is less than 0, then we'll have an ellipse. And the third one, if this guy is greater than 0, then we'll have the hyperbola. And then for outside the discriminant, we also have that if when you add a plus c, you're getting 0, then you have the hyperbola that is a rectangular. A rectangular hyperbola. The one that has its axis a slant one. So it's not on the x-axis, not on the y-axis, it's on the slant axis. So then we also do the translation here. If you work out this guy, you can introduce some rotation that can eliminate the bxy from the general equation there. So that's those equations that we use to eliminate that one. Okay, so we talk about rotation. So there's an angle. So if I'm having a x squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0, then this guy can be rotated by an angle, some angle theta, to a form that will give us a new Cartesian plane where instead of it sitting on the xy, it will sit on the x prime, y prime. So here we're interested in, because we move from the xy, we introduce the x prime, y prime. How then do we move? Which equations help us to move? That's our interest here. So they're saying the rotation equations. So we have a set x is equal to x prime cos theta minus y prime sin theta. We also have y is equal to x prime sin theta plus y prime cos theta. This is very, very important. Then out of this, you can also, if you're given a rotated equation, you can reverse it, where you say x prime is equal to x cos theta plus y sin theta, and y prime is equal to negative x sine theta plus y cos theta. Now we're talking about theta, so we should also have an idea of where that theta is. Well, how do we get that theta to use? Because for you to say cos theta, you know the theta, and then you evaluate it, get a significant number, then use that number as a coefficient of x prime as you take it in the general equation. So how do you obtain that theta? So we have two, where one, we have options of cot 2 theta being equal to a minus c over b, and the second being tan 2 theta, which is b over a minus c. You know the issue of cot and tan. Cot is 1 over tan, tan is 1 over cot. So when you reciprocate there, you know you get the other one. Okay, so this is a very good summary of this topic so far. So we can now go to the tutorial sheet and see how we can appreciate this information that we have here. So we do examples. And see how we survive there. So we go to question 2, where we'll find A there. Question 2A, put each of the equations for the hyperbola in standard form and find the hyperbolas foci, vertices, asymptotes, and hence sketch the graph. So 1, 9x squared minus 16y squared is equal to 144. So we just say discuss. So first thing, you say, okay, if I'm given this equation, the standard one has a 1 on the right. So the first thing is to divide throughout by 144, divide by 144, and divide by 144. So this will give us 9 into 144. It should be 16. So that here we have y squared over 9 is equal to 1. And then when we have this structure, so our a squared is equal to 16, and our b squared is equal to 9, telling us that our a is equal to 4, and our b is equal to 3. So our c squared is a squared plus b squared. So it will be a 9 plus 16, which is 25. And so c is going to be 5. So when we go for a sketch, we'll say, okay, this guy has a vertex at 4, at -4, and at +4. So it has a vertex here. So it will go like this. And then it has the foci C, so at -5 and at +5. So it's centered at 0, 0. And then our directrices, they have to pass here. And what did we say is the equation of the directrix of the asymptotes? For that case, centered at the origin, we have this case here. So y is equal to plus or minus a over b. Now for that case, let's confirm here. So y is b over a for the first case. It's supposed to be b over a, this one. B over a, and then the other one is a over b. Okay, so when we come here, we're saying asymptotes y is equal to a plus or minus b over ax. So b is 3 over a 4x plus or minus. So we know that this guy is coming this way. So to come this way and go this way, where we label the down one as y is equal to -3 over 4x. And then the other one as y is equal to 3 over 4x. Positive to that. So it means that, so in this case, normally, the b, in most cases, when you're discussing the hyperbola, is not shown. Okay, but it's coming from the vertex, you hit these lines. So this distance here is b. So since we know b is 3, so this is 3. So if I hit this line, down here, I have -3. So we have this box that is a rectangle in here. Like that. So that's how this guy comes in. So we've got so many nice questions here. We're out of time. I want us to, when we get back, concentrate much on the questions where you're given to find the hyperbola, given the center, given the foci, the center, and the asymptotes, and also the one where you're given where you're given the vertices and the asymptotes. So we'll pause here and get back in 10 minutes time. So let's keep time. So until 1945 we'll be connecting.